Good afternoon, everybody. We are today here in the International OWASP Application Security event. We are with Antoine from Escape. Thank you very much for being here.
Thank you very much for your invitation.
Guys, we are facing a new stage where we are doing a lot of development based on artificial intelligence. We are having a lot of profiles and these kind of things. So the way of developing application is changing a lot. You agree, or how do you see these changes in the development based on this artificial intelligence?
Yeah, so that's true because at the CTO of a tech company, we're also obviously using AI for our work basically every day. We can see that obviously AI makes us gain a lot of productivity. So that's a fact. But at the same time, we can see that developers, they tend to use a lot of auto-completion. Like they love doing tab. And so I would say that developers, they never really cared about security, but now I feel like they care even less. And AI tends to be super verbose, to write a lot of code. And indeed, there is rising concern about potential vulnerabilities that can be introduced into all that code that is produced every day, definitely.
Yeah, because at the end, these models are trained with data that probably contains vulnerabilities, and they are replicating or providing or copying and putting these vulnerabilities also in the new code or the code they provide. As the developer goes very quickly, they don't review, they don't take into consideration deep inspection to find these things, and this is a new way to put newer risk or the same risk than we had before, but with less visibility. What's your view on that point?
Yeah, so absolutely. So we're coding faster with AI that, as you said, are trained on existing data, so potentially existing vulnerabilities. So the AI, they can, at least today, they definitely can reproduce patterns, even malicious patterns or patterns that they have seen in previous code bases. There is a lot of debate about that. We will be able to have AI that produce secure code. So for now, this is not the case. We have some hope that this is going to happen. But more importantly, I think that in this quantity of code that is produced, so far, if you talk with developers, you will see that they, especially with experienced developers, you will see that AI tends to over-engineer a bit the code and produce too much code. And sometimes they even produce dead code, like a function that they never import helpers and everything.
Yeah.
So definitely it can create vulnerabilities, potential new vulnerabilities, but also false positives. For example, if they produce dead code, you can have a static analyzer that would say, hey, there is a vulnerability in this function, but this function is not imported everywhere. So this tends to create a bit of noise currently, I would say, with the current tooling.
It's true that this dead code that you mentioned provide vulnerabilities that has an impact in the actual security of the application. Probably this is referring to the existing or the traditional vulnerabilities in the code, but using these copilots or these assistants also includes or could include also new risk based on new ways of attacking the artificial intelligence models with prompt injection and all data set that could expose information and this kind of thing, right?
Yeah, absolutely. This is indeed another problem. So basically, developers, they love building over AI, upon AI. So they're making API calls to whatever the LLM is behind it. It can be a self-hosted LLM or an OpenAI hosted LLM or whatever. So this introduces multiple risks. First, all the risks related to the prompt engineering itself and to the prompt injections, as you mentioned, of course. And it also introduced new kinds of vulnerabilities that are all about leaking some data, potentially customers' data, customers' information, through requests that are going outside to outside servers. And personally, so I'm also building a cybersecurity company. We have a lot of customers that are asking questions about, is the model stored in-house? I mean, do we host it ourselves? All the data going outside? What is the risk of the data being stolen during the HTTP request that is made outside of our servers and everything? So there is a lot of concerns and questions about that, definitely, for sure.
Yeah. With this, with these all changes, actually the traditional tools that was based on these traditional vulnerabilities need need an improvement. For example, to remove false positive, we need to analyze the reachability of the code in order to improve if something is reachable or not, to remove noise and to put focus on actually what is important to remediate. We have to detect new ways or new vulnerabilities, new risks, new attacks. So we need additional detection capability. We need to prioritize all these new type of risks. So how do you see the evolution of these new tools? Because, for example, we detect or we have clear that we need, reachability analysis, exploitability or something based on the context. We need new detectors. It's not just about SAS. It's not just about the software composition analysis. We need to detect if a developer is using a model that has downloads from a website, for example, the data that is exporting to train something in the cloud. So we need additional capabilities to find new scenarios and new things. But
that's absolutely true. So if we just stay at the static analysis level, so we just consider the code by itself, let's not talk about dynamic testing for now. Just let's talk about the code, as you mentioned. Sure, the main problem we have currently in that there is an overproduction of code, of first-party code, basically.
Yeah.
And anyone can build code now. Even in marketing teams, they tend to build their I think sure they are doing this. They are doing their own scripts and everything, all their own servers and APIs, and they tend to expose more. So companies, they tend to export more and more code that has to be secure because obviously this is first-party code that has to be secure. The classic solutions, the way they are working now to adapt to this growing number of lines of codes, is that they tend to use the former static analysis techniques that were there before, and they tend, as you said, to reduce false positives using AI or to try and find. I mean, we really keep this engine, this rule-based engines to detect vulnerabilities. Okay, so I think that there will be definitely a new generation of tools incoming. In the meantime, we kind of have this in between where we have old generation tools that are compensed with AI to reduce false positives and maybe find more patterns. But we are definitely going towards a new generation of tools that are using AI themselves. Yeah, this is the kind of it is.
And I have for the final the AI on AI is interesting.
Yeah, it's AI versus AI.
Yeah.
So AI introducing vulnerabilities or trying to exploit vulnerabilities. I think
AI
trying to
detecting,
AI
AI resolving. Yeah.
Basically, this is what's going on right now. This is really interesting because you can see that as in the end, who is going to have the best algorithm and the more computing powers.
Yeah. It's who monitor the monitoring tool. It's a recurrent thing. Yeah. The other thing is, we have a new generation of tools detecting new risks, new scenarios and everything, but at the end, the developers are doing a lot of auto-generated code because they are always running, lot of speed is required to deliver everything. At the end is how or where do we check the security of application? Because some time ago, it was at the end of the process. We were moving to the left. Now it's moving to everywhere just to check as soon as possible in the different places or at the end, we have to check in the developer environment, you have to check in the CI/CD system, you have to check in the other.
Okay. So this is a very vast question. I don't feel like we should just focus on one part, but this will still be a world where the whole chain should be secured. Okay. So technologies should adapt because there is more code. So, for example, if you focus on SaaS, again, we should avoid reaching a position where you have so much alerts going on in your ID and everything that you basically just end up disabling both copilots to code and both the SaaS to security vulnerabilities, and you say, oh, well, it's too much, it's overwhelming, I stop that. So I think like it still makes sense to try to find vulnerabilities at the static level. If we discuss about SCA, however, for example, I have a strong opinion on this, which is that before you were importing a lot of libraries and you were just basically using one single function, but that was really well built and super optimized and everything. So you were importing the whole library. So you had a lot of false positives with the SCA because you had all the functions that you don't use that are actually maybe raising potential alerts. So hence the reachability analysis. Here, I feel like we will reach a point where AI will be able to just code for you the right functions in a secure way that you need the helper function to import from the library. Maybe it would be more relevant now to build it yourself so that you have a whole piece of code that is isolated, you just use it yourself, and not necessarily import it from an external library. Yeah. So maybe this is just a hot take, but the importance of SCA will reduce over the next years. Maybe. Okay. This is just an hypothesis. As for everything that is more dynamic security testing, so this is more my field of expertise. I really feel like it's becoming more and more relevant, okay? Because before the main drawback of Dast, while it was basically just testing missing headers on APIs or websites, and it was not really able to test the business logic in depth of application. So basically it was just creating noise. Like we had a period a few years ago where we said really Dast is dead. This is a dead category.
Yeah.
Now, definitely, it is becoming more interesting because if you build Dast solutions based on the latest advances in AI, you can really focus on what matters and find real business logic security issues. We have a few POCs at Escape that we are currently building based on AI. And this is striking how in a very few number of requests, using AI properly and splitting your problems properly, you should not overwhelm the context window of LLM, so you should really split the problem in small parts and everything. You can build AI agents that are able to find very complex vulnerabilities that are true positives, that are really analyzing the app in the applications in their environments. So they're actually finding true positives. And you have companies, for example, such as Xbo currently, which is very trendy in the US because they claim, more than they claim, they are actually ranked first on HackerOne. And basically they claim they do everything using AI agents. So what is going to happen to pentesters? Will pentesters be replaced by more dynamic, a new generation of Dast tools? I think this is where the market is going. Obviously, Dast is my specialty, so I'm a bit biased here. But I feel like this is really exciting because as a child, I always dreamed to
get in the moment that the momentum, everything is changing in the both sides. Because as you mentioned, the SCA, for example, is okay. The auto-generation capability of code is using invented a component, for example. Not just using one method. Is okay. this component actually doesn't exist. So someone is attacking, putting some malicious component that has the name that has injected in the model to generate the code. So the thing is, we need new capabilities, because even you have to stop the developer using that component. So you need to analyze all the components as soon as they have published in the registry in order to block usage of this malicious component even before downloaded or in the first pipeline, because in other way you are going to put by probably not intentionally by the developer, but you are going to put more things there. And you have mentioned you are using artificial intelligence. We are using artificial intelligence to reduce the noise because of the reachability in the code, or we are using artificial intelligence for the SaaS resolution or the SaaS out of it. So at the end is this AI on I, because we use the AI to monitor and to detect vulnerabilities in the AI code generated for solving the things. So it's interesting debate.
It's really interesting debates, and I think like it's important to maybe to be able to know where does the codes come from. So basically, I think with regulations and maybe and everything, we are going towards a world where to secure the code generated by AI, it would be great that it's explicitly stated that this part of the code base has been generated by AI, maybe not reviewed properly yet and everything. So this can be a way to
using the regulation, because at the end we have agents generating code, agents reviewing code, agents solving vulnerabilities in the code. Who is going to approve? Who is going to monitor that everything is working there? Do you think that regulations in Europe, for example, are going to do something to force the organizations or whatever to have some special checks for this type of code generation or application?
Yeah, indeed. So this is exactly what we say. We start having blue team and red team agents, and they're going to fight with each other, and in the end, it's just gonna be who has the best computation for basically.
At the end, we are going to have purple agents.
Yeah.
So at the end, they are going
agents.
to simulate everything just to learn how to defend.
Absolutely, and purple agents in the middle. So that's pretty exciting. As for regulations, I think that would be really useful for compliance, especially that would be able to force companies and developers saying, hey, yeah, this part of the code is generated by AI. What percentage of the code base is generated by AI? Maybe these will be figures that you will have to see in compliance reports on everything. So this is what's happening in Europe right now. So I just come back from San Francisco, however, and I can see that here, people, they don't really care about regulating right now. They're more about exploring what can be done with AI in every field. Especially in San Francisco, we can see there is a real intensity about. I can see no entrepreneur. They are building ventures. In a few weeks they have 300K of revenue, and they say, okay, that's not enough. Let's throw everything away. Let's start again. So there is a great emulation there. So we will see also if Europe can hold the emulation that is coming from the United States. So this will be really interesting to see if regulation are going to slow down the base, not worldwide, or just maybe impact the innovation here. We'll see.
Okay. Thank you very much, Antoine. Thank you very much, Jesus. A pleasure, and thank you very much to everybody. I hope you enjoy this session and these days with the training sessions and the visits to the stands. Please visit our websites to know more about our solution.
Thank you very much.